Check whether the vectors are coplanar or not. Okay, let us begin. First, what we'll do, we'll name the vector. So let us suppose that a vector is represented by I cap plus 2 times j cap plus 3 times k cap. Then we have the vector b. Vector b is represented by 2 times I cap plus j cap plus 3 times k cap. And then we have the vector c, which is represented by I cap plus j cap plus k cap. Now, what we'll do, we will suppose that all these three vectors, let a vector, b vector, and c vector, let these three vectors be coplanar. Although we need to check that they are coplanar or not, but we'll begin with an assumption that they are already coplanar. Now, if they are coplanar, this means that if we pick up any vector, let's say we pick up the vector a, this can be expressed as a linear combination of the other two vectors. That means we can represent a as x times b vector plus y times c vector, where x and y are going to be two scalars. Now, what we'll do, we'll substitute the value of a vector. We have I cap plus 2 times j cap plus 3 times k cap. This is going to be equals to, now we need x times b vector. So x times b vector is going to be x times 2x times I cap plus x times j cap plus 3x times k cap. This is going to get added to y times the vector c, so y times I cap plus y times j cap plus y times k cap. So we now get I cap plus 2 j cap plus 3 k cap. So that's going to be equals to, we'll combine the like terms on the right hand side. So we have 2x added to y. So this is going to be I cap, then coefficient of I cap. Then we have x added to y. That's going to be the coefficient of j cap. And then we have 3x plus y, which is going to be the coefficient of k cap. When you compare both sides, we're going to get three equations. First equation is going to be 2x plus y equals to 1. We're going to label this as equation number 1. Then we're going to get the next equation, x plus y. This is going to be equals to 2. So that's equation number 2. And then we have 3x plus y equals to 3. This is going to be equation number 3. Now what we'll do, we'll take two equations at a time. Any two equations at a time. We can pick up either 1 and 2, or we can pick up 2 and 3, or 1 and 3, and solve for the value of x and y. Okay, let's do one then. Let's pick up equation number 1 and equation number 2. So what we'll do, we'll take equation number 1, and from here we're going to subtract equation number 2. So that's going to give us 2x minus x, that's going to be x. Y and y get cancelled out. 1 minus 2, that's what's going to give us negative 1. So we have x value equals to negative 1. Now what we'll do, we'll substitute this value back in equation number 1. So we have 2 times negative 1 added to y equals to 1. So we have y equals to positive 3. So we've obtained the value of x and y. Now what we'll do, we will substitute this value back in equation number 3 and verify whether if it satisfies equation number 3 or not. Now in equation number 3, we have 3 times x value is negative 1, added to y, so that's positive 3. This is going to be equals to 3. Now we have negative 3 plus 3 equals to 3, which gives us 0 equals to 3, but that's not true. That's incorrect. So this means that the values of x obtained by solving equation 1 and 2 is not satisfying the third equation, which means that our initial assumption was wrong. We can say that hence the three vectors, a vector, b vector, and c vector, these three vectors are non-coplanar. Because they're non-coplanar, it simply means that we cannot express it as a linear combination of the other two vectors.